Hi, everyone. Okay, so we are not covering determinants in class today, and thus this year. And so I'm leaving it as an extra credit option for you. It's an incredibly rich topic. It is super useful. And for those of you that are going to journey into the SAT, if they're still offering it this year or next year, this is on it. So it is a very helpful topic. It's leading us into a process called Cramer's rule. But in order for us to understand what the heck that is, we need to understand determinants. Thus, oh, and before I forget, this is chapter 11.3 in your book if you'd like to refer back. Okay, so here's the determinant. Let's assume that we've got A, B, C, and D, and they're real numbers. Okay, we don't deal with the determinant if it's in the imaginary world, imaginary number world. And this is called a 2 by 2. 2 rows, okay, 1, 2 by 2 columns, 1, 2. So we call it a 2 by 2. In order to calculate the determinant, we take A times D and subtract it by the product of B times C, leading us to this. Okay, very simple, very straightforward. So let's practice. If we were to calculate the determinant, it would be, okay, this is A and B. And let me do it in a different color so it stands out a little bit for us. Okay, it's horizontal A, B, and then C, D. So then we're going to take A times D, so 5 times -2, and subtract the product of the other two numbers. And it always goes top to bottom, so 6 times 1/3. A times D, 6 times 1/3. Continue calculating with me. We get a -10 minus 6 times 1/3 gives us 6/3 or 2. So the value of this determinant is -12. Negative numbers are okay. Remember, we're dealing with real numbers here. Well, you might actually be asked to evaluate a determinant with a number on the outside. This represents -2 times this 2 by 2 matrix. So we're going to do just that. The determinant will be -2 times whatever the determinant from the matrix ends up being. Again, in the top row, we have A and B, and in the bottom row, you have C and D. And then we multiply top to bottom, so A to D and B to C. Or, yes, to make sure I'm saying that right. Hey. Okay, so 3 times 0 minus 4 times -3. All right, keep calculating with me, please. We have a -2 on the outside of 3 times 0 is 0. -4 times -3 is a +12. So ultimately, we are having to calculate -2 times 12, and that leads us to a -24. Now, your determinant won't always be negative. It just so happens that these two examples were. Okay, so that's how we calculate the determinant. Why do we need it? Because it will help us solve a system of equations. And that, ladies and gentlemen, is where Cramer's rule comes into play. Oh, I'm going to sneeze. I'm going to pause. And Cramer's rule is what we use to solve a system of equations. Yes, we can still use substitution. Yes, you can still use elimination. And of course, you can still graph to find their point of intersection, which is their solution. But you can also use Cramer's rule. So let's say we have two equations. Take a look up here. Oh, gosh. Okay, we've got AX plus BY is equal to S, A, B, and S being all real numbers. And then you have CX plus DY is equal to T, C, D, and T being all real numbers. How we solve is this. X is equal to the determinant of the given values over the determinant of the coefficients. Okay, the top, pardon me, the top determinant has the coefficients and the solutions. Okay, same with y, coefficients and solutions. This is just the determinant with the coefficients. How you can write it is like this. The determinant of x, so d of x, and what we do here is we substitute in the solutions for all the coefficients of the x variable. And then to find the determinant of y, we substitute the coefficient or the solution, in for the coefficients of the y variable and calculate. And in finding these very simple ratios, we find what the variables of x and y are in the solution. Now, it's important to note that the determinant of the coefficients altogether cannot be 0. Why? Because it's in the denominator, and you cannot divide by 0. You cannot have a fraction with a denominator of 0. It then becomes undefined because it doesn't exist. It can't be calculated. Okay, let's try it. A lot of words I just threw at you per normal, right? But then when we start practicing, it gets a little bit easier. Okay, notice ABS. Okay, so ABS, CDT, CDT. So first thing is we need to find the determinant of the coefficients. So I'm going to do that one in black. The determinant of the coefficients, well, I'm going to set up my matrix. So it's 2, 4, 3, and -5. Keep everything in order. Okay, don't move things around. And then we're going to calculate it just like we calculated the previous two. So top to bottom, A to D. We're going to have 2 times -5 minus top to bottom, B to C, 4 times 3. Keep calculating with me. We end up with -10 minus 12. And so the determinant of the coefficients for this system of two equations is -22. Okay. Well, in order to find x and y, we need the determinant of x. And that's when we take these solutions and substitute them in for the coefficients of the x variable. All right, how does the matrix look? It looks like this. 16 and -9 replace 2 and 3. 4 and -5 stay there. Okay, top to bottom, A to D. That means we have 16 times 5 minus 4 times -9. Okay, well, 16 times 5 is 80. -4 times -9 gives us a positive 36, and we end up with 116. Okay, keep going with me. The determinant of y. Now we're going to take the solutions and substitute them into the coefficient column of the y variables. So A and C are 2 and 3, but we're going to have 16 and -9 over here. Here we go. A times D, we get 2 times -9 minus B times C, so 16 times 3. All right, working this out, we get -18 minus 48, which leaves us with -66. Okay, we found the determinants, all three, the coefficients, determinant of x, determinant of y. In order to find x and y, we have to complete the ratios that you saw up here. Okay, doing that for x is, oh, my pen decided to poop out, the determinant of x divided by the determinant of the coefficients. Substituting that in, we get 116 all over -22, and then we're going to hope that it reduces. So let's think. 3, no. 8, no. I don't think it does. So let's go back and see if we made a mistake, because with the determinants, we have to be really careful. Yep, and we forgot the -5. Now, if you caught that, way to go. Nice job. If you didn't, And then this leads us, if we were to compute, the correct calculation, we would get -44. There we go. That's going to divide evenly. Now, yes, fractions are okay, but usually the examples I'm going to give you will divide evenly. So go back and check your arithmetic. When we divide this, we get a +2. And then for y, we put the determinant of y over the determinant of the coefficients. We end up with -66 over -22, which is a +3. And ladies and gentlemen, our solution is 2, 3. Now, just like you would, if you wanted to, with any system, you can plug this in and see if it actually makes it true. If I take 2 for x, and I'm using the first equation, and I plug in 3 for y, it should work out. We get 4 plus 12. Yep. So these two numbers make the first equation true. If I were to check in the bottom equation, we would get 3 times 2 minus 5 times 3. We end up with 6 minus 15. Does that equal -9? It sure does. So we know that 2, 3 is a solution to this system. You do not have to, pardon me, you do not have to check these, but it's nice to know that you have that option in case you're a little shaky on your arithmetic or how you set everything up. Okay, so what I'd like you to do now is pause the video, and I want you to try this one on your own, referring to the example that we just did, and then unpause and check your answer. Okay, hopefully you paused it and you gave yourself the chance to learn and see how you were doing. So remember, determinant of the coefficients is always the denominator when we're solving for x and y. I found mine to be 42. It's always a to d and then b to c, and we subtract those products. And then to find the determinant of x, I just substituted in the solutions for the coefficients of x. So then I had a to d minus b to c, and I got 168. Then we take the solutions and substitute them in for the coefficients of y to find the determinant sub y. A to d minus b to c, and I got -84. Then to find x and y, we simply take the determinant sub x and divide it by the determinant of the coefficients, and I found it to be a +4. And then to find y, the determinant of y divided by the determinant of the coefficients, and I found it to be -2. Now, the last thing I didn't mention on the previous example is that you have to always yep, you have to always write your answer as a coordinate. Because remember, you're solving for x and y. You're solving for an intersection point. You're solving for a location where these two lines will intersect. All right, so that's a system of 2. Now, what about a system of 3 unknowns? Is that even possible? Yeah, totally is. And how? Well, some of you saw how to solve a system with 3 unknowns through substitution and elimination, and some of you didn't, and that's okay. What we're going to do is we're going to use the determinant and Kramer's rule to solve a system with 3 unknowns. Okay, so let's say we have a matrix that you can see on your notes here, and we call this a 3 by 3. Okay, 3 columns, 3 rows. Well, in order to find the determinant for a 3 by 3 matrix, we take the first number and create a matrix with the bottom right 4 values. You can see that right here. Okay, then we look at the middle number, and notice we're subtracting. Okay, that middle number goes out here, out in front of the matrix, and in fact, I should have highlighted the previous one, sorry guys, goes here. And what we do is we then create a matrix with this line and this line. So you can think of it as, if I'm using a sub 12, I don't use those values. And so the matrix is created with the remaining 4 numbers. Okay, if I were to use a sub 11, which is the very first one, then I don't use those row and column. I use these 4 numbers. Okay, if I were to use the last one, which is the last matrix and determinant that we're going to figure out, which is a sub 13, well, now we're adding. So the first one is subtraction, the second one is addition, and that means I don't look at that row or that column. I'm going to create my matrix with those 4 values, and then we figure out what the determinant is. The remaining 2 by 2s, we call those minors. Now, I'm not going to test you on the vocabulary, but it's nice to know so that if you are working through these problems with others and they use the vocabulary, you understand what we're talking about. Okay, so subtraction, addition, minus, plus, and the remaining 2 are called minors. Now, there's a different way we can expand out the determinant. We're not going to look at that. So for those of you that decided to print out the note guide, don't worry about that piece. For those of you that are writing this down, don't write that down. Okay, here we go. We are going to evaluate a 3 by 3 determinant. Off we go. Now, it's nice because I have the ability to highlight and erase. You guys can just circle and erase if that's helpful for you to have that visual. So 4 is the first number in the upper left-hand corner. I don't use that row or that column. So that means 4 is going to be multiplied by this 2 by 2 matrix. And then remember, it's subtraction. Okay, so then the next number in the top row that we need to use is -1, which means that we aren't going to use this row or column. So we have a -1, and the matrix that it's going to be multiplied by is 6, 0, 1, 4. And then we add, because it goes subtraction, addition, minus, plus. Okay. The next number in the top row is 2. So that's going to be multiplied to the next matrix, but we don't use that row and we don't use that column. So we have 2 times 6, -1, 1, -3. And we are now set to go to calculate the determinant of this 3 by 3. All right, are you ready? The answer is yes. Here we go. Be careful with the signs. Very, very important. We have 4 times top to bottom. Okay, so we have -1. Oh, golly. I'm jumping ahead of myself. -1 times 4. Remember, when calculating the determinant, even though this is a 3 by 3, the determinants of the 2 by 2s is always subtraction. Okay, so calculating the determinant of a 3 by 3, it goes subtraction then plus. Calculating a determinant of a 2 by 2 is always addition or subtraction. Okay, it's always minus. So -1 times 4 minus 0 times 3. And then we have subtracting a negative, so I'm going to go ahead and put +1. A times C, so 6 times 4 minus 0 times 1. And I said A times C, but I meant A times D. Yep, killing it. And then we have +2. Top to bottom, A times D, so 6 times -3 minus, because we're calculating the 2 by 2 now, these are the minors, B times C, so -1 times 1. Once we have everything plugged in, we can now start to calculate with just basic arithmetic. We have a 4 on the outside. -1 times 4 is -4 minus 0, because it's 0 times 3, plus 1. 6 times 4 is 24. 0 times 1 is 0, plus 2 on the outside. 6 times -3 is -18, minus -1 times 1, which is our -1. Keep going with me. So this is 4 times -4 plus 1 times 24 plus 2 times -18 plus 1 gives us -17. If we continue to calculate, we get -16 plus 24 minus 34. Whew, we are almost there. Aren't these a doozy? -16 plus 24 gives us 8 minus 34. So the determinant, ladies and gentlemen, of this 3 by 3 matrix is going to be -26. All right. I know that it seems like a lot of work, but when you solve a 3 by 3 system of unknowns, yeah, that's a lot of work. So this is a nice option. Now, remember, this is just the determinant. We use Kramer's rule. That's right. We're going to do all of this with Kramer's rule to solve for x, y, and z. Normally, and if you'll look at this example down here, we'll just call it example number 1. Actually, we already had an example number 1. Let's call this example number 2. This system of 3 unknowns, we have a column of x's, y's, and z's, and solutions or constants on the outsides. So this is what a system of 3 unknowns looks like. We're going to use the exact same process to determine what the determinants are. Now, notice up here, okay, same thing you saw before, d sub x over d. This is the determinant of the coefficients. D sub y over d, d sub z over d, which means that, again, our determinant of the coefficients, like it's stated right here, cannot equal 0 because it's in the denominator of the fraction of the ratio. We can't divide by 0, right? It would be undefined. Okay, so how do we find d sub x, d sub y, and d sub z? exactly how we did with the 2 by 2. We're going to take the solutions and sub them in for the coefficients of x, for the coefficients of y, for the coefficients of z. And yeah, you absolutely might need a little bit more space on these because as you saw, we are working some things out and they are taking up some space. So let's do it, guys. Let's first find the determinant and hold off on this, okay? I'm going to go into this space for this example. You guys have more paper. Yeah, flip it over if you printed these out. If you started this after the quiz, then most likely you're writing it on your own piece of paper. Space it out how you need. Okay, so the determinant of the coefficients, write them out with me. We have 1, 2, -1. Second equation, 2, -4, +1. Third equation, -2, 2, and -3. And I can't stress enough, be careful when you're transferring these into your matrices. One wrong sign in all this work, you're going to be really frustrated. As you saw with my 2 by 2, right? Okay, first one. We have the first number in the first top row is 1. That means we're going to have a 2 by 2 that's right here. Okay, so we have -4 times -3, top to bottom, -1 times 2. Then we subtract, because with the determinant of the 3 by 3, it goes subtraction and then addition. So 2, and we're going to use this row and this row. And I wonder if, okay, I'm getting ahead of myself. Let's do this. I think this will be better for us visually. My apologies, and thanks for hanging in there with me. Okay, so 1 is the first number in the top corner, right? Which means these 4 create our 2 by 2 minor matrix. And I'm just going to write it out before I start to calculate. And then we have -2 goes on the outside with this row, or column, sorry, and this column. So let's write it out. We have something to refer back to. 2, -2, 1, -3. And then we're going to add. And what are we going to add? We're going to add this value with this minor matrix right here. So we have -1, and then 2, -4, -2, and 2. I like that better because it allows us to see what we're multiplying rather than trying to keep up with the 3 by 3 placement. Okay, here we go. Now we have 1 times, determinant of a 2 by 2 is always subtraction. So -4 times -3 minus 1 times 2. And then we have -2. 2 times -3 minus 1 times -2. Plus -1, because that's that number in the upper right-hand corner, times 2 times 2 minus -4 times -2. Okay, here we go. 1 times -4 times -3 is 12 minus 2. And then we have -2. 2 times -3 is -6 minus 1 times -2. So we have +2. And then I'm just going to put -1 because we're adding a negative. And that leaves us with 4 minus -4 times -2 is 8. So we'll put -8. So then keep going. Oh gosh, pen. Okay. Then we get 1 times 10 minus 2 times -4 minus 1 times -4. Almost there. 10 plus 8 plus 4, and our final answer is 22. So that's the determinant of the coefficients. Okay, well, obviously I ran out of room. This is super important. We will look at it in just a minute. Let's go ahead and figure out what the determinant of or sub x is going to be. This is where we replace the x coefficients, that first column, with the solutions. So the solutions are -3, -7, and 4. Be careful when you write these down. There's a lot of room for error. Coefficients of y are 2, -4, and 2. So 2, -4, and 2. And then the coefficients of z are -1, 1, and -3. So -1, 1, and -3. Make sure I have that right. Yep. All right, so we're going to take that first number in the first left, or in the top left corner, negative 3 times the 2 by 2 of these guys, which is negative 4, 1, 2, and negative 3, minus, because in a 3 by 3 determinant, we subtract the next quantity, so that's 2 times the 2 by 2 from these columns, so negative 7, 1, 4, and negative 3, and then we add the number in the top right, which in this case is negative 1, times the 2 by 2 of these 4 values, negative 7, negative 4, 4, and 2. Off we go. So negative 3, top to bottom. So negative 4 times negative 3 minus 1 times 2. We're subtracting because in here, because we're just calculating the determinant of the 2 by 2. Okay. And then times negative 7 and negative 3 minus 1 times 4. Minus 1 because we're adding a negative. Negative 7 times 2 minus negative 4 times 4. All right, keep calculating with me. Negative 4 times, this becomes positive 12 minus 2. Minus 2, this becomes 21 minus 4. Minus 1. And we get negative 14 plus 16. All right. Then have negative 3 times 10 minus 2 times 17 minus 1 times a positive 2. So negative 30 minus 34 minus 2. That leaves us with negative 64 minus 2, and negative 66 happens to be d sub x. All right, what I'd like for you guys to do is pause and calculate d sub y and d sub z, and then we'll come back together and do it all together. Okay, how do we do? Hopefully for d sub y you got 11 because we substituted the solutions in for the y coefficients. And then for d sub 7, we substituted the solutions in for the third column for the z coefficients, and we should have gotten 22. Okay, now in order for us to solve for x, we take d sub x over d and reduce. In order to solve for y, we take d sub y over d and reduce. Fractions are okay, remember. And then for z, d sub z over d and reduce. So our solutions written in coordinate form in alphabetical order x, y, z should be negative 3, 1/2, and 1. Whoo! That's good stuff. And the reason why, or how we know these can work is if we go back up to the top and we solve for x, y, and z. If we plug it in, is what I meant. So if I plug in negative 3 for x, 1/2 for y, and 1 for z, we should get negative 3. We should get negative 7 and 4 when we work it down. All right. Okay, the you try. I want you guys to try this, pause the video, and then when you come back, we'll talk about the solutions we may have found. Again, so hopefully you paused and you worked out the you try. Setting up the determinant of the coefficients, we should have found it to be negative 5. Now, the nice thing about this video is you can pause when needed, okay, to fix something on your notes if needed. And the determinant sub x, we substitute the solutions in for the coefficients of x. Hopefully, once you work it out, you find that the determinant sub x is negative 5 as well. For d sub y, now we're putting the solutions in for the middle column, the coefficients of the y variable. And you calculated, hopefully, negative 15. For d sub z, now the solutions are going in for that third column for the z coefficients, and we calculate positive 10. When we create our ratios, we should have come up with 1, 3, and negative 2. And if you substitute them back into the given equation and then you try, they do all work. So, sweet. Whew, it's a lot of work, I know, but it's kind of exciting. I love puzzles. So, inconsistent versus dependent. So, if you find that your determinant is 0, right, we'd said that it can't be. So, let's say that we solve it and it is. and at least one of the d sub x, d sub y, or d sub z's is different from 0, then we say that your system is inconsistent, which means there is no solution. So you either say that it's the empty set, right? Or we can say no solution. Now, if your determinant is 0 and all of your determinants equal 0, then we say the system is consistent and dependent, which means there are infinitely many solutions, and the system must be solved using row reduction techniques. Now, if in the practice that you come across either one of these situations, we either put inconsistent and no solution, or I want you guys to put consistent and dependent because we haven't yet figured out what that row reduction technique is. Okay, great.